In this demonstration, I will show how to create a benchmarking program or a benchmarking function which we can use to find out how long a certain function takes to run. We are going to use this to find out which one of these three functions, which one is faster. So they all do the same thing at the end of the day, but the code inside is a bit different. Here we have some if statements inside the loop, and we have some ifs and elifs, a little bit better, and here we have taken all the if statements outside the loops, but other than that they all perform the same task. So the first thing I will do is I will create our driver, and I'm going to call it the benchmark function. So this is what will fire up and run our functions. So I'm going to also ask the user to choose a file to open, and I'm going to store that path separately, and then I will create a picture file from this file path, and I will display this and show what actually happens with if we call one of these functions. So we need to pass in the picture object, an adjustment factor, which is a parameter of the problem, the value that we are going to adjust by, and the color channel, and 0 is for red. And if I run this benchmark, and if I choose a big enough picture, this is a medium-sized picture, to be honest. So you can see the color changed, and it takes about 3 to 4 seconds to run, which is good for testing purposes. So the next thing I want to do is I want to find out how long it takes to run each function. So I'm still running the same function. What I want to show here is that it's not really entirely obvious how long or how many seconds it takes, and you will also see that it actually takes different amounts of time each time you run it. So I will demonstrate that now. Now, to find out the actual time taken, we can't use a stopwatch. We can, however, rely on the internal clock of the computer and use it as a stopwatch. To do that, we're going to use the time module in Python. And the time module comes with a nice function called time. So time.time, and if I assign the value from that to start, and if I do it again and assign it to another variable called end, and if I print the difference between end and start, it'll actually show me the time in seconds it took for me after typing this and hitting enter until I took to hit enter on the second statement. So it took me 4.82 seconds in between. So that's a very accurate measurement of the time taken. So let's do that. Let's import time, and I will say start and time.time, and then you can see how I'm doing it immediately before calling the adjust color function, and so I'm getting the start time immediately before, and I'm getting the end time immediately after. I'm not mixing it up with the repaint statements. In fact, I'm actually going to get rid of the repaint statements because I know that I know that these functions work, and I know the end result. So I get the start time and I get the end time. So what can I do next? I can print the difference. So if I want to see the outputs immediately, I need to say printNow. So printNow works very similar to how print works, except it displays results instantaneously, whereas print sometimes takes a bit of time. So I can say printNow end minus start, and that should show the time it took. So if I run this now, not that one, if I run benchmark and open up one of the files I opened earlier, I can see that it took 3.76 seconds. and if I open the same file again, I will get a slightly different value, 3.98, and if I run it again, I'm going to get yet another value. So it's not consistent at all, and you will get a little bit more consistent values if you open up a large enough picture. So right now what we should do is get some timing measurements from multiple runs, or we want to take multiple timing measurements. To do that, I will create a loop, and I will say for r in range 0 to max runs. So max runs is a variable telling or a variable containing how many times this timing experiment is going to be done. 3 is not a lot, but to demonstrate how this works, I'm just going to limit it to 3. So this is going to be repeated 3 times, and at each time it's going to load the picture, start the timing, call the function, end the timing, and print the difference. And let's see how this runs. If I call benchmark again, and I will be able to see the measurements like that as it's going, because I'm using printNow. If I use print, I won't be able to see it until the whole thing finishes. Alright, so I got a bunch of different numbers, and the next is, find out what's a good way to figure out an accurate value that's indicative of how long this thing takes. So that's when the statistics come into play. So we want to take the middle value, right? The median is one metric. You can take the longest time taken, but that's not ideal, because sometimes it just might take too long to run because of some other background process or something. And the shortest time taken is also equally unreliable. So the median value is the middle value, but the numbers have to be in ascending or descending order. So how do we do that? We can add these numbers into a list. So I will create an empty list called timing list. So the way you create a list is actually quite similar to how you create a regular variable, except when you assign or when you initialize it, you put open and close brackets. That's one of the ways, or this is creating an empty list at least. So I do that, and then what I can do is I can say this value that I'm printing out, I want to append it to this list. So to do that, I call the list.listName.append function, and then I will add the difference that I printed out earlier. Now the timing has already been done. The value that's printed here is the exact same thing that's going to be entered here. So that they are not going to change just because I'm doing it one after another or anything, because the timing started here and the timing ended there. So that adds everything to the list. I can say print timing list. Now that will just display the entire list. As I said, we want everything to be sorted, so I can very easily call the other convenient function, the list name dot sort, and that will sort everything, and I can print it after. So this is before sorting, and this would be after sorting, and then I want to pick the middle value. So that would be the median, and I can say timing list, and we know how many timing values are there. There's going to be 3 in this case, or whatever the max runs has, and to get the middle one, we say we divide that by 2. So that's going to very nicely pick the middle element for us each and every time. So let's run this and see. Run benchmark, and again, so this is just going to do it 3 times, which is nowhere near enough to get a statistically significant number. If you have to run it maybe 40 odd times to actually get some reliable timing values. So in this occasion, so we saw this is the order in which they were added to the list originally. That's how it happened. And after sorting, we got things like this, and the middle or the median is that one. So by increasing this to 40 or 80, something like that, that's a good, that'll be pretty good to get a reliable median from. So the next thing you want to do when you're comparing would be to uh, call the other function 47b after taking the values for 47, and so like that you get the median values for the three different functions and you compare them. So when I did that earlier, and I did this based on 41 runs, and see those are all the values, and I got some pretty close medians. They are running a little bit slow right now because the recording is taking place, but 47b ran a bit faster than 47c, and so you can actually find out which one is actually faster, even though uh, another one might be theoretically faster. So it depends on various optimizations that are performed on different platforms and things like that. So um, for that, um, there's no other option but to take some measurements and see. So I will stop that there because 30 is a lot.